In this video, I'm going to show you guys how to make a pro BlueGhozt controller using our new 3D printed boxes. So I've done a few videos now over the years on making a harness for the BlueGhozt controller, and as with most of the stuff that I do, I end up picking up new tricks and techniques, and I wanted to share with you guys the current way that I'm making the controllers. A few different changes have happened since the last video, so it's definitely worth a watch if you make your own harnesses using the BlueGhozt controllers. Previously, we had got these designed and mass produced that would enable you to be able to extend a Ghost box to make it a larger controller box for things like adding in our power savers. So if you follow our Instagram or the Ghost Lighting page, you'll see that Dan over at Ghost Lighting had actually created a 3D printed version of the Ghost boxes and made it available so that you can download them and print your own boxes. And I was talking to him about that, and I got the go-ahead to take his design and extend the box and add a threaded hole for a cable gland. And the idea behind that was to come up with an alternative to the original design for our extension boxes that was initially created by Justin Whelan and then modified a little bit to better suit the battery saver itself, which then went to an engineer to have a solid file created and molds so that we could get them mass produced. And that is our Ghost extension boxes that we currently have available on the website. And once again, those are designed to extend the BlueGhozt box and make it larger. Now, a common issue with this though is that if you make our controllers the way that I make them, you have the holes on the Ghost box themselves that have to be covered up. And then you also have the seal around the two boxes that has to be covered up when potting. And then when everything's said and done, even though it does look pretty darn good, you do have a very notable difference between the box, top box and the back box. And while that's not necessarily a bad thing, I don't think there's anything wrong with doing that. And I was perfectly happy doing those controllers and sending them out. I do really like the idea of just a one solid box. And effectively it is the same overall dimensions as the other one. It just eliminates those extra holes that you have to cover up and that offset from the old box to the new box. Notable downsides are the printing on it. Now, if you have a multicolor printer, you can get a little bit creative with the logo and make it look pretty cool. I'm still dialing in some of the settings on it, and these files are available on Maker World right now. You can download it and print it on whatever printer you might have. But I am working on refining my printing processes and materials to the point where I'm confident enough to sell them. So they will probably end up on the website at some point. But once again, by all means, download the file, print it yourself if you have access to a 3D printer, and save yourself a few bucks. But yeah, it does definitely have a better uniformed appearance if printed well on a printer. So I think I'm going to be switching to this style now for my stuff. Now, as far as the 3D printing goes, if you do go that direction, I do recommend that you use a good material for temperatures and things like that that you might see under the hood of a car. PLA is not a good option. PETG is, you're pushing it with PETG. I think PETG is okay. Thermally speaking, it usually is fine. But something like ABS or ASA is going to be much better. And you could even go beyond that. If you want to go overboard, you could get like polycarbonate or nylon or something like that, which I think is a little bit overkill. But, you know, even carbon fiber reinforced materials like PETG, carbon fiber might be a decent option. There's so many filament options out there. The biggest thing is just making sure that it's going to be good under the hood of a car long term. PLA would probably be the number one that I would say don't even try it. But beyond that, you know, try some different filaments and see. And that's kind of the cool thing about it being a 3D printed file. Once again, purpose of this video is to show you how to build a Pro Ghost controller using these new boxes. So I'm gonna show you guys the parts that go into it, and for the most part this is a lot of the same parts that are in some of my older videos, but I'm gonna go over it again, and I will have a link in the description of this video to an Amazon page that has anything on there that's available on Amazon. And then a lot of these parts are going to be available on my website as well. And then some of the tools you could either get on Amazon, or in my case, I got a lot of this stuff from Harbor Freight. They've been really good tools. So we're going to cover a lot of that stuff, just what all is involved, so that way you know what you're getting into. So first up is the BlueGhozt Plus. Now we're going with the BlueGhozt Plus this time. There's a benefit to it, and we're going to show you that in a little bit. But basically, it is going to simplify the whole process of the controller itself and its operation. So we'll go into more detail on that a little bit later on in the video. So in this case, we're going with a Plus. Then beyond that, you're going to want your box. Now, you can slightly modify this installation, obviously using our extension boxes if you prefer to go that direction. The only difference being that you'll have to screw in the hole for the cable gland, and I typically do that in the Ghost box itself. So it's right up there lined up with the board. So that would be the biggest difference that you'll have between this and that, and either method is perfectly fine, just depending on what your preference is about going about putting the controller together itself. Once again, understanding the fit and finish of a 3D printed part is generally not going to be able to be the same as a molded part such as this. So, you know, this is a proven molded part, and I can certainly understand why some people might prefer an ABS molded plastic over a 3D printed plastic. So, you know, either option is available. This is the way, once again, that I'm going to be going until I have a reason not to. Next up, you're going to need a battery saver. Once again, these are available on the website. Most of you guys have probably at least heard of them by now if you're not using them already. And we will go into more detail on the wiring of this, but it's effectively a smart relay. It is going to stop the addressable LEDs that you use in your build from killing your battery, as well as protecting the addressable LEDs in your build from voltage shocks on the car, which seems to be the #1 reason why LEDs go bad. These addressable LEDs, especially the 5-volt ones, SK, seem to be rather sensitive to voltage shocks. So low voltage is, in my experience, what kills SK 6812 LEDs. And that's why battery savers have become a big part of what we're doing here. That's why our ProFlow controllers now only come with battery savers. We want you guys to have the best experience possible with addressable builds. Trying to create a little bit of an ecosystem here where, for the most part, if you get something from us, you have confidence that it's gonna last and it's gonna do okay. That's our main focus, and that's where we're trying to go. And the battery savers are a huge part of that. If you're not using a battery saver of some kind at this point and you're having some issues, you probably should consider adding the battery savers to your offerings for your customers. And once again, these are sold like this for use with the BlueGhozt controller, and they are built into our SP105E based controller known as the ProFlow controller on our website. A couple more components that you're going to need: a 11mm cable gland. These are available on the website. I believe they're $1 a piece or something. They're pretty cheap. You're going to take the nut off of that, and this part will just screw right into the threaded hole on the 3D printed box. So pretty cool there. Now, when you are putting that in, I do recommend that you use some Gorilla Glue. We're going to go into detail on that a little bit more, but I have seen that even though these threads are pretty well matched, it will leak. If you pot these controllers, it's going to leak through those threads. So you do want to line them up with a gasket of some sort, and I really like this stuff for a gasket. It works really well and it's easy to work with. Moving on to the power side, you do want to have some kind of a fuse holder like this, and we do sell these on the website as well, pretty cheap. We got 14 gauge wiring made on them with the fuse under the cap here. They do come with a 15 amp fuse already installed, but these are very common fuses to replace or upgrade if necessary. 14 gauge being the gauge of choice for me and my builds on controllers. So these are available on the website. Next up are heat shrink ring terminals. Now, any ring terminal will be fine. I mean, ultimately, this is just your power connection. In some cases, you might not even want a ring terminal. You might want to hardwire it into a power source of some kind. But in general, when I'm shipping these to people, the understanding is that they have a bolt of some sort at the battery or something like that that they can attach these to and secure in place. So I like these. I really like the fact that these are heat shrink on the bottom. So I can hit it with the heat. It shrinks around the wire. It holds in place really well, and they work well. These particular ones are 5/16, and it does depend a little bit on the car that you're doing. Most of them are 1/4 inch, but there are quite a few that are 5/16, so definitely keep that in mind as to what size you might need for your application. But I like a 5/16 because it seems to kind of cut the middle. It's not too big for most applications, but it's not too small for those few applications where you need something a little bit bigger. For the connections to the lights, I really like these barrel connectors. I've been using them for a few years now. While ideally you want something that's going to be like an 18 gauge wiring. They don't really make it in something as big as 8 or 6 pin plugs. So while you could go with something like a douche connector or something like that, I really like the barrel connectors and the simplicity of them, the sturdiness of them. These are not going to be ripped out. If you're connecting or disconnecting, sometimes you get customers, they don't grab the plug as much as they grab the wire and pull. And if you have something where you've crimped the connections on, I in the past have had a lot of issues with customers pulling wires out. So I got away from those. I started using these. I've had far less issues. They're easier to run because they're very small and they can fit through holes in the car. I just really like this style, and that's what I've stuck with. Another thing I like to use is expandable braided sleeving. This is 3/8 inch, and once again, I will have the link in the description for all this stuff. You're gonna want 3/8 inch, roughly. You can go a little bit smaller than that if you want to, but 3/8 is a pretty good rounded size that I use. That way you don't have a ton of different sizes, but it works pretty good. I got some various lengths here. Generally, I do like an 18-inch length, another like 12-inch length for the power, and then I do like a 6-foot length for the far side, the long wire that goes from the controller. Next up, we have our signal wires here, and these are like your turn signals, DRLs, as well as a couple signals inside the controller for like your EXT, and these are 20 gauge silicone wires. I do have a link for that as well. I've been using these for a while, and they are very high quality, and being silicone, they can take a lot of heat and stuff like that, which in general isn't really even necessary, but they're super flexible too, which is what I really like. They're durable, and they're pretty easy to rip the sheathing off. You can just do it with your fingernail and rip it off. So they're really easy to work with, really forgiving, and they hold up really well. So these are my go-to. I've got yellow, 2 yellows, the same length, so about 6 foot on one, about 18 inches on the other. I got a white that's about 18 inches, and then I've got just some other random color, whatever you want it to be. This is going to my EXT from the battery saver, so I have that as well. And then I do have a short red for power, and it doesn't have to be the BN Tech, and honestly the colors don't matter as long as you know what is what. When you're wiring everything up, you can do something different, but you know, if you're going to be doing a bunch of controllers, having a bunch of different colors so that you can mentally keep track of what is going to help you in the long run, so consider doing that. Up next is our power wire, and I do use 14 gauge for the main power going in, just considering that this is split between all LEDs. They go across this one line, so I like to make the main power line a 14 gauge. I just haven't had issues with 14. It's probably overkill for most of the builds that I do, but I like consistency and doing what works, and so far this wire works. It's quality, it lasts, it holds up. I get controllers back or headlights, or if a car comes back in, these wires are still working perfectly fine. I don't have issues. I got them on my own cars. I don't have issues. So just another one that I really like. I do have a link in the description on Amazon for that as well. Moving on to your LED power lines. Now I go 18 gauge on the power lines for the LEDs. You know, 14 is nice, but at a certain point, you know, 14 gauge can get a little bit expensive. If you're running 6 foot lengths, it really does start to add up. And so this is what I have been using for a long time, and I actually sell this on the website now. So I ended up liking it so much after trying many different things over the years, stuff on Amazon and stuff like that, and was able to get these on 100-meter rolls, and they're really good quality wire. It works great, it's good quality, and this is rated at 18 gauge. Once again, I do a 6-foot run and about an 18-inch run for each light. Up next is a short power and ground connection that'll go inside the controller. I just do 18 gauge. You don't need anything crazy on this one. Thinner is actually a little bit easier because this is going to be a low load on this wire itself. So I go with 18, and I do actually sell rolls of this as well on the website if needed. Moving on to shrink tubing. Now, I like to use one of these big ones here on the cable gland right on the end like that. It makes a little bit of a cleaner connection there. Keeps all the wires nice and tight, makes it look really nice. This one's like 1.5, 1 3/4. Like I said, I'll have a link. I got to double check the sizing on that, but yeah, the larger one here, this is a 3-to-1 shrink tubing, so it will shrink down quite a bit, and it is adhesive lined, which is really nice. Once you do hit it with heat and it does shrink down, it grabs a hold of whatever's inside of it, so I do like that. Up next is 3/8 inch of that same 3-to-1 adhesive lined, 1/4 inch of the 3-to-1 adhesive line. 3/16 inch, this one I do 2-to-1 because of the locations that it goes to. 3-to-1 is not a bad idea if you do go that way. I don't, and I haven't had an issue with it. So I stick with the 2-to-1 3/16 inch, and then 3/32 inch 2-to-1 as well. So there are quite a few components to this, but in the end, when you get a roll of this and a roll of that, you know, you've got a ton of material, so it does end up lasting for quite a few different controllers. Moving on to tools. Now you're gonna need a Phillips head screwdriver, a small flathead screwdriver, a pair of wire cutters, and I like the ones that have the little crimp inside of there. These are called linesman's pliers. This particular set I got from Harbor Freight. This is a set that I was using for years and it still works and I still have it here. These are channel locks. You can get them on Amazon. These actually, like I said, I had been using them for probably 4 or 5 years. Just only recently decided to get a new pair, and I'll say they do cut really well for a brand new pair, but these definitely last. Channel locks, quality stuff if you want to go that way. Or Harbor Freight, super cheap, easy, accessible, and they do have lifetime warranties, so, you know, pretty cool. Wire strippers, these are gonna help make life a lot easier. You put the wire in there, you clamp it together, it spits it out. These are also at Harbor Freight. Now, I've bought these from Amazon and every other listing. I think I even got them. I'll link a few on Amazon as well if you want to get it that way. Seems like they're all about the same. I've bought stuff from Irwin, I've bought stuff from Quinn, I've bought many different brands over the years, Keen tools as well. I don't think any of them worked better than another one. I've tried other ones, like I do have these, and occasionally when it's like a really tight spot, these are kind of nice because they got a little better clearance than what those do, but for the most part, they don't work as consistently well as these do. And then I've got a set like this. I think I've even got another 2 or 3 sets of different styles that are like completely different styles of wire strippers. But ultimately, when it comes down to it, I can put up to like 4 different wires in here, 18 gauge, and just strip them off, and it just works. These are my go-tos, is this style. These are from Harbor Freight specifically, and that's what I'm using today. And then, you know, probably not a bad idea to have a pair of scissors or something so you can cut wire, cut the shrink tubing, cut anything like that. You know, these work well for that. Gorilla Glue contact adhesive, and this is very important. I tell people all the time, it's contact adhesive. A lot of people hear the Gorilla Glue, they go and they buy the Gorilla Glue, which is more like a super glue, and it's not the same thing. Contact adhesive. And if you've used this stuff, if you've ever used it on a build and then had to go back into the build and remove stuff, you'll really appreciate just how well this stuff works. It dries to almost like a Plasti-Tack kind of consistency, but it bonds really well, so it's peelable, but it holds, and it's got like a vibration resistance, which is one of the reasons why I just keep coming back to this stuff. So a lot of the stuff that we deal with in cars is vibration, so LEDs inside of a light, things like that, you want to have some kind of a vibration resistance, and this works really well for that. And it also creates a really nice gasket, and that's what I use it for in the case of this one. Now, there's not a whole lot that I actually have to use this for with the 3D printed box, but I will be using it on that cable gland when I screw it in there, because that seems to be the one part where it can leak. In the event that you are going to be using the original Ghost box and the extension, you're going to want to put it around that seal right here between the 2 halves, because that is a leak point. So that would be a case where you would use this, and you'll see what I mean about how easy it is to remove, because once everything is dried, you're gonna wanna remove that glue that you have around that seal, and it just peels right off and it looks pretty good. So Gorilla Glue contact adhesive. Next up, you're going to need something to shrink the heat shrink tubing down, and I like a heat gun. And they make tons of different heat guns. This one's like an arts and crafts one that I bought years ago, and it's honestly perfect for what we do and shrink tubing and things like that. It's not gonna remove paint on a wall as well as a big gun style one would, but this one just works, and I've had it for many years and it's still working. And if it's still available on Amazon, I'll put a link up for this as well. It's a really good one. Like I said, it's many years old. I'll be a little bit surprised if they haven't updated the model or something at this point, but it's a solid gun. And last up is your solder and soldering iron. Now, if you guys have watched a lot of my videos, you'll see that I've been using these Sugons for quite a while, to the point where I even started selling them on the website. I'm out of stock on the 245s. I do need to get more of those, and that is something I want to do at some point. But if you are doing this stuff professionally, if you do this stuff a lot, you're really going to appreciate having this iron versus any of the other ones that I've used. Now, obviously, you could spend more money and get a better iron. To step up from this to something better, you're going to be going from like $150 clear up to like $500 to $1,000. So it's a big step to go up from this. But this is a big step from something that might be $50 or $20 or even $80. A lot of the ones that I was seeing, some of the Wellers, even on the lower end, you can get a Weller for like $100 and they work okay, but this just works better. I just love the quick change tips. I love how small it is. It just feels like a Sharpie in your hand. It works, it's consistent, it lasts. The tips are easy enough to get a hold of, but they're not cheap. But the tips last. I think I've replaced one tip, had to replace one tip the entire time I've owned this thing, and I use it a lot. I keep it on, I don't even turn it off. It heats up so fast. This is definitely an iron to go with. It's gonna make your life easier. And it is 120 watts, so it does heat up really quick. And it also maintains heat a lot better than a smaller iron might. So the solder you use is gonna make your life easier. If you're using a lead-free solder, it doesn't flow as well, it requires higher temperatures, and it takes a little bit more time. You might even need to use some flux or something like that to get it to flow better. While you can do that, and there's nothing wrong with that, this stuff is just less prone to user error, less prone to having difficulties flowing. You are messing with electrical components, and when you're touching a iron that's running 350C, 400C, and you're touching an electrical component, you do have the chance of overheating that component and frying circuits on it. So you should keep that in mind when you're working with this stuff. Ideally, you really don't want to be using something that's going to make you have to keep that extreme heat in contact with that part for a longer period of time than you need to. And that's where a good lead-based solder can really help out there. Now, it is leaded, so it does have lead in there. You do have to consider that. Wash your hands. You probably shouldn't be eating food while you're soldering, but in general, this is the stuff I've been using for years. It works really well. I'll have a link to this as well. This particular brand is Kester, but I think the big takeaway is you want a leaded solder with a rosin core. So first up, we're going to open up our BlueGhozt box. I've already removed the screws there, and we're going to pull out our BlueGhozt controller. Now on our website, you'll see an option on your BlueGhozt controller. You can get flip terminals or normal. Normal orients the screw terminals here so that the wires go out the side of the box. So these holes here, that was the intention of Ghost when they designed this, was so that you could run the wires right out the side of the box and make everything really easy to wire up, but that doesn't make it waterproof, which is ultimately what you want under the hood of a car. And that is where we ended up opting to get these flipped. Now we do them in-house here. Actually, the boards come in and we solder on these connections ourselves with the flipped terminals like this. And you'll see that it is actually oriented where the wires will go in. So you see on the website, it says flip terminals or normal. You want flipped terminals for the purpose of this controller harness build. So first thing you want to do is go ahead and loosen up any of the screws that you're going to be using. Now, I do not run my power through the Ghost controller. There's just no real benefit in doing that. The only thing that your LEDs need from the controller is the data. So I like to run my power separate from the controller and only power the controller itself. So I will just do my data 1 and my data 2. And I'm going to loosen those screws. I'm also going to loosen power, ground, Park, EXT, TR1, and TR2. I'm also going to do my plus switch and my SW1. For the case of a headlight, we're not going to be worrying about our reverse or our brake, but if you are building this controller for a taillight, you're going to want to make sure that you run wires to that as well. Something that you can do if you're building a headlight controller and you want to have more control over separate colors is you can run your reverse and your brake two different wires. Basically, you can use your brake as a demon eye or something else by wiring it into your DRL. So that way when the DRL is active, the brake will also be active, and you can program in a demon eye or a section within the light to be on the brake only and turn everything else off on the brake. Basically going to be within your settings on the block tab where you can select each section and you can tell it when to activate. If you go in and manually choose to not have any activate on the brake, even if the brake is triggered, nothing will light up. So what this gives you the ability to do is to activate certain sections. So if you have a demon eye or you have a little strip section on a light and you want to make it a certain color, you can do that. For this particular controller, I'm actually building it for a build where the customer wants his demon eyes to be red on one side of the car and purple on the other side of the car. And I'm gonna be able to do that by adding in this brake line to my park. And that way we can have 3 colors running when the DRLs are on. One thing to remember about this though is that when you use the brake or reverse, you will not get the startup animation of your DRL or your turn signal animations to work on that section if you're using a brake or reverse input for that. There's a few different ways to bridge this. You can run a wire from each one of them and splice that wire together inside the controller, or you can take your soldering iron on the back side of the PCB and just bridge your park and your brake just like this, so that your park and your brake are bridged, and we're just bridging on the back side for the park and brake, and that way in the event that the park is activated, the brake will also be activated since they are linked on the back side here. Very important if you do this that you don't link any other areas that you don't want to link, like your ground or your reverse. You want to make sure that only the park and the brake are connected that way. And before you do this, make sure the controller works and everything is fine, because if done properly, that can create some issues. So you definitely want to make sure the controller's working right. So now I'm going to take my LED wire and I'm going to run that first. I'm just going to take both wires and strip away just enough to get it plugged in there and separate the wires down so that I got just my data point. And then I'll just tighten it down with the screws. You want to give it a little bit of a tug, make sure it doesn't pull out, and you're good to go. Now I like to take these and strip them out and then splice them together. Once again, I don't run the power or the ground through the Ghost controller for the LEDs. I run that separately. Up next, we'll grab our turn signal and DRL wires. Now on the board, it is marked data 1 and data 2, and it is marked turn signal 1 and turn 2, or TR1, TR2. TR1 by default correlates to data 1, and TR2 by default correlates to data 2. So if you're running a short wire for one side of the car and a long wire for the other, and you want everything to work by default without having to go into the settings and make adjustments on which side is turn signal for which side, you're going to want to match those. So I'll take my short wire and I'll run it to the same side as my other short wire. So in this case, data 2 will be my short turn signal wire, and data 1 will be my long turn signal wire. Now we're going to run our DRL, and I'm going to run this wire for my EXT. Next, I'm going to run my 18 gauge power, and that is going to go to the power and ground. Then I'm going to take a short red wire, and the color of the wire doesn't really matter, but I use red just to kind of keep track of what is what. This is going to go to my plus switch, and I'm going to take another one of these wires here, and I'm going to run that to switch 1. Now, it's important that you double check all of the wiring going on the board here. Make sure everything's in the right location, but even more importantly, make sure that you don't have any strands of wire that might be touching an adjacent terminal. I'm using 18 gauge. It's a little bit bigger. It's about the limit of what you can put in these screw terminals, and there is always a chance that you might have a strand of power touching the strand of ground if you didn't get it right in the hole just right. Now this is going to create issues for you. The controller won't even turn on at all if the ground and the power are touching. So definitely want to look that over, make sure that everything is in its hole and only in its hole, not touching other adjacent holes or parts on the PCB itself. Now we're going to start combining a lot of our wires together. Now, once again, this is going to be our main power wire. We've also got the LED power wire, which is right here. We have our ground right here. We have power and ground going to the Ghost controller itself, and we have power going to the switches. You do not have to run a ground for the switches. That is actually bridged within the controller. They do not bridge the switch power because that needs to be a 12 volt power, but the Ghost controller is designed to work at 5 volts or 12 volts. So those are separated powers. So you do have to run power to both the switches and the Ghost controller. You do not have to run a ground to both. You only have to run a ground to the Ghost controller itself. So I'm going to get a look in here size-wise. I'm going to bring this wire back so that they're about the same length there and cut it. And then I'll strip those back. Next, I'm going to take the rest of this 18 gauge power wire and strip some of it out. This is going to connect to our battery saver. So that is why we're splicing it separately. Go ahead and split it and strip the ends off. Do the same on these. Now, first off, you're going to want to get all of your grounds together. We're going to do this one as well. Go ahead and get your 14 gauge. So we got all of our grounds ran together. I'm going to go ahead and hit that with some solder. Next up, we're going to do our power. Now, there are going to be two main power points. You're going to have your power that goes to the LEDs, and you're going to have the power that goes to pretty much everything else. So in here, we got our main power. This is this one here. We have our power that's going to go to the power saver. We have the power that goes to the Ghost controller, and we have the power that goes to our Ghost controller power switches for the Plus. We're going to splice all of those together, and then we're going to add in a single piece of 14 gauge power wire here. This I just get from the 14 gauge wire that we used for the main power line. And I'm just going to strip both ends of that, and I'm going to connect one end to this same main power line and hit that with some solder. And then we're going to take the other end of that 14 gauge wire and connect it to our LED power. Now we're going to take some of our 1/4 inch 3:1 shrink tubing, cut that down to 3 lengths about 1 inch long each, and these are just going to go over top of our powers and ground. And just like that, I got the shrink tubing covering up our main powers and our ground to make sure that nothing touches inside of the light. And now we can move on to our battery saver. So we're gonna go and grab this. Now, a couple key points on these if you're not familiar. This remote is linked to this power saver, meaning that if you lose this, you will lose its function. You can reprogram these, but if they're waterproof, if you've potted them, you're not gonna be able to get to the contacts to reprogram them, so you're gonna be SOL. So this is very important not to lose. These can be cloned. If you go on Amazon, and I'll put a link as well, they do have clone remotes that you can use. These are 433 megahertz, and basically you get a clone remote, and as long as you have this remote, you can clone it as many times as you like. So if you're worried that you're gonna lose a remote and you wanna have an extra, that's an easy way to do it. It's pretty cheap to do, but you need to do it initially. We do not have the ability to replace a lost remote without having to replace the battery saver itself. So please keep that in mind. Now, moving on to the battery saver. They are marked here. This is your power and this is your ground. Now, this is what powers the RF transmitter as well as the activation for the relay itself. This must be 12 volts. So in the case of our controller, that's gonna be no problem. But in the event that you're doing a 5-volt controller, you're trying to change things up, you're gonna make it so this does not work. Ideally, you wanna have 12 volts going to this controller. You can run 5-volt inverters inside of the lights. That's the way I generally do my builds. Moving on, you have your output. This is gonna go to your EXT on the BlueGhozt controller. This is what's gonna activate your show modes when you want it. Then you have 3 triggers on this, and these triggers allow you to activate the relay automatically under certain circumstances. So if you wanna run it to a DRL, or a turn signal, or brakes, or an ACC on the car, you can do that. But the case of the Plus, we're only gonna have to run 1 wire to any one of these 3. Now I'm just gonna choose this one right here in the middle because it really doesn't matter. And this way, if I were to, for some reason, have a rogue strand that is connecting 2 of them together, it won't matter. If you have a rogue strand of your input connecting to the output, you will fry the battery saver, so don't do that. You cannot send 12 volt into the output on this controller, and you cannot send 12 volt power into the output on the Ghost controller, on the Plus. So these are very important. Do not do that. Don't get those mixed up. Those are outputs on both, and if you send 12 volt in, it will overload the circuit and you will fry that controller. So be very careful on that. I'm gonna go ahead and loosen up the screws on those 4 points. And then we're gonna move over to the bottom here. Now this is basically your switch. This big thing here is a relay, and this relay is a automated switch. It turns on and it turns off. And basically what we're doing is we're putting the power going in one side and power out on the other side. And this switch just activates and deactivates that connection. So what we're gonna do here is we're gonna open up the NO and open up the COM. And in the case of what we're doing here, it really doesn't matter which one you go to. You can run power from the car to the NO or to the COM, and then you run power out to the LEDs through the opposite. So it really doesn't matter which one you do because this is just a very simple switch on this side. That's really all we're doing. So at this point, I like to go ahead and get all my wires oriented. Now, typically I have these going out of the cable gland in this direction. So I'm going to orient that. I do have my power and ground here that's going to go to the battery saver. So I'm going to pull that back. And then I do have my triggers for the turn signals and the DRL that's going to go out the cable gland as well. So I try to run those this way. I have this power here is going to go to the battery saver. So I want to run that up this way, and I'll just orient everything just like that. First thing I'll do is cut off a little bit of this excess. You want to have just enough. You're going to have this battery saver sitting right on top, just like so. So you want to have it to where these wires can go into this terminal with a little bit of slack. You don't want a ton of slack, but you want just enough. So, you know, kind of get an idea, eyeball it to whereabouts you think it'll be. Maybe cut an extra 1/4 inch, not much, and then strip off just enough that you can run it into the NO and the COM. So just like that, I'll run them into the NO and the COM, hold them in place, and screw down these connections. Now, on the other side, we're gonna have our power and ground, and that is going to go to the power and ground on the battery saver here. So we'll go ahead and cut that down to, once again, just enough. You don't want to cut it too short, but you also don't want to have a ton of extra wire in there. And once again, your VIN, as marked on the board, is your ground, and the plus is your power. And once again on this, it does need to be 12 volts. 5 volt will not work for the RF, and it is not enough power to activate the relay. So it must be a 12 volt connection going to the battery saver. On your power in and out, that can be 5 volt. That does not matter. It's just the part that powers the relay activation as well as the RF transmitter that needs to be a 12 volt signal. Now, moving on. I did use the same color wire here, which can be a little bit confusing, but I know which one is which. This one here I can see is going to my switches. That one is going to be the one that activates the relay. So I'm going to cut it and run it to that trigger 2. And next I'm going to take the other wire, which goes to my EXT, and I'm going to run that to the output. So I'll show this a little bit more detail when we get to the application part and setup for this controller. But basically what we're doing is we're going to use one of the 12 volt outputs from the BlueGhozt Controller Plus and run that to activate the relay. And we're able to make that more automated within the controller by changing a few settings. And then I run from the output on the battery saver to the EXT, and that way we can use the remote that's included with the battery saver to activate pre-programmed show modes. And I do have a video that goes into more detail about programming in show modes within the controller. I'll try to briefly touch that on this video, but if you want to know more about overall programming of the BlueGhozt controller, you're going to want to watch that video. If I remember, I'll try to put a link at the end of this video for that. And that's it. So that is the wiring of the two controllers together. Now, what we're going to do is we're going to take our box here. I am going to go ahead and add in that gasket, our Gorilla Glue contact adhesive, to the threads, and then just screw that into place. And then I'm going to take the rest of the wires that we have here and just kind of try to keep them together. First off, I like to run the silicone wires here because they can be a little bit flimsy and a little bit hard to shove through that 11 mil. But just like that, I could run all 3 of those right through. And then I'll go ahead and run in our LED power and then our main power line. Now I'm just going to work it down in there so that we can get our BlueGhozt controller. Got our BlueGhozt controller down in there, and then we'll get our battery saver just like that. Now there's one more thing that you are going to want to do on your battery saver, and that is deactivate the B button. So if you're familiar with the battery saver, there's 2 buttons on it. The A button activates that EXT trigger on the BlueGhozt controller, and basically we can use that to activate party modes on the fly. The B button is a manual activation for the relay. So in the case where you pair it with a light, if you're at a car show or an event and you want to show off your lights but you don't want to have the car running, you need a way to manually activate the relay, and that is what the B button can do. Now in the case of what we're doing here, it's going to be much more automated. The BlueGhozt controller itself is going to control when the relay turns on and when it doesn't. So anytime the LEDs get a signal to say that they need to be running, the BlueGhozt controller will tell the relay to turn on as well. Now that means that we don't need the B button, and the B button actually just creates a lot of confusion for a lot of people. That's one of the reasons why I went with the plus now instead of using the lights. I had a lot of customers that unfortunately could not figure out if their controller was on or off, and they would frequently have issues getting the lights to work because they didn't realize they had to push the B button, and they would frequently have issues with remembering to turn the lights off, and then they would defeat the entire purpose of the battery saver and their batteries would be dead on their car. So I decided to opt out for the Plus, and that's what I've been using now on all my builds. And you do need to make sure that you deactivate that B button, or else you might inadvertently push that B button, activating the relay, leave it on without even knowing it, and then end up having dead batteries. So we want to deactivate that. Now, as with everything, make sure everything works before you do any of this stuff, because if done improperly, you can create damage to the components. So you want to make sure the components are good before you attempt this stuff. So check your battery saver, check your ghost controllers, make sure all that stuff is working right. But assuming it does, it's pretty simple. All we have to do is break the contact on this tracer right here on the back of the battery saver. Now you can do that with a Dremel, or you can do that with some other tool like that. I like the ultrasonic cutter. I can just activate it. And just like that, I can go over that tracer, which breaks that contact point, and now I've disabled the B button. And it's important, you're not trying to cut through the board the whole way. The way these work, there is contacts on the front and on the back. And the only thing you're trying to break is the contact point on this side of the board. So you don't want to cut through clear to the other side of the board. You're just scuffing that surface so that you can get down just past. Now, if you're unsure if this has worked, you can connect your power and you can check. Just as simple as taking this power wire here, you can strip the ends off and connect our power and ground on the bench. You take this remote, hit that B button. Does it click? If it clicks, then you didn't cut enough. If it doesn't click, then you're good. So you can see, I push the B button, it does not click. I know that I'm good to go. Go ahead and disconnect the power and ground. And a real quick point to make here, you do want to make sure that you do not connect the ground to power and power to ground. You need to make sure power goes to power, ground goes to ground. If you get these mixed up at any point installing in the car or something else like that, you're very likely to fry the battery saver and the ghost controller. So it's very important that you do not get power and ground mixed up at any point while using these controllers. All right, so now we can put our back on. Now you do have the back that comes with the BlueGhozt. It does not fit on these boxes, so you won't be able to use that, but the one that is 3D printed will fit on, and you can use the same screws that came with the Ghost controller to secure the box in place. Now I'm just gonna do this temporarily because we will need to get to it after everything is wired up and tested. When we pot the controller, we're gonna have to pull the back off to do that. So I'm just gonna do one in each corner. That'll keep the box lid in place while we're putting the rest of the controller together. One more area where you are going to need a gasket is in between the wiring in the cable gland itself. I have had many times where the potting compound will actually make its way through the wiring and create a mess when everything is drying. So you're gonna wanna make sure to go in there and do that. I just pull the wire nut back, and then there's this little gasket in here, and you wanna try to pick this out as well and pull that out of the way. Then you're gonna take the same Gorilla Glue contact adhesive, and you're gonna wanna put it between all the wires. So you're gonna kinda like separate them a little bit like this, and just pump it all up in there. And then just the whole way around the outside. And then we'll go ahead and put our little silicone gasket back in there, and then tighten down the nut. And that will dry and create a watertight seal where the potting compound cannot get out. So for the short wire, we're going to have our short turn signal, our short DRL, and our short LED power data wire. And if you want to, you can electrical tape that there to make it a little bit easier. I just fold it right over like this and then run that sleeving right over top. And then next, we'll take our longer one with the single turn signal and do the same. And then last up, we'll do the same for our power and ground. Now for the power and ground here, I'm going to put a little piece of shrink tubing over top of that before I slide it back over to make it a little bit easier to get it on there, and then just slide it back to the base all the way. And for the power wire, you're gonna wanna keep in mind that we're gonna be adding a fuse in there. So when you're measuring it out, you're gonna wanna keep in mind of that. I will just cut that in half like that, and we'll figure on our power being about like so, and then running back to about this far. So I want my braided sleeving to go about that long. So I'm gonna cut that to length right there. And a little trick to keep this stuff from unwinding, which it tends to want to do pretty easy. I can take the tip of my soldering iron and just kind of like tap down on the tips there, and it'll melt them together. And that way they hold their form and they don't try to unravel on you while you're sliding everything over. And I'm gonna get it just far enough where some of it is still sticking out past the wires, and that'll make it easier for me to get my shrink tubing over top. I'm gonna get that on there, and then I'm just gonna slide it up to the controller itself. Now we're gonna take our big shrink tubing and put that over all 3 of them. And just like so, I can shove that right up in there, and I'm gonna go ahead and just hold all 3 of these together along with pushing that shrink tubing up against the box. Now I'm going to take the heat gun and shrink it down, starting at the base, and just like that, try to get it as nice and uniform as you can. I like to hold these together, kind of let it cool down. The 3-to-1, if it's hot, it's still malleable pretty much. So if you hold it in place like this and you kind of let it dry, it will hold its form better than if you just let it go and then it kind of like tries to spread. If you want to speed up its cooling down a little bit, you can kind of, put your hand on there. It's a little hot, but it'll help to cool it down a little bit quicker so that it holds form better and it just looks better in general. But as you can see there, it just makes it look a little bit more professional than just having the wires coming out of a cable gland. It'd be really difficult to run the braided sleeving into the cable gland. That would probably be a cool idea if you could do that, but it's not quite that simple. So this is just a really nice way to be able to clean it up a little bit, make it look a little bit nicer, and it also holds form better. This helps to add rigidity so that people are less likely to bend and potentially cause issues right at that connection point. So first up, we do have our power and ground here, and I'm just going to split those down and then just go just a little bit past and then cut that power like that. Now I'm going to take this and strip it back. I'll take my fuse holder and strip it back, and these are 2-way. It really doesn't matter which side that you strip down and which side you connect. It doesn't really make a difference. And then we're going to use our shrink tubing again and run that over this and splice those together. And for wiring splices like this, I like to run them just like so, where you keep a nice low profile, just like that. Now this is easy to pull out, but as soon as you solder it in, it's gonna hold in place really good. So when you're doing it with solder, this is a really good way to do it. And just like that, we got it soldered in place. We're gonna go ahead and put that shrink tubing over top, hit that with heat, and then we'll move the braided sleeving with the shrink tubing up around that. Try to stretch it out so that it looks nice and uniform and not kinked up. Hit that with heat, and then we're just gonna strip back on the ends here. Now, I do like to keep these staggered. Main reason being, like in the event that you're connecting it to the battery, it's a lot less likely that the power accidentally touches the ground while you're connecting it or vice versa. So I do like to keep them staggered, and I just go right like that. Just cut just enough off of these so that we can get our ring terminals right over top. Then we're going to use these wire cutters here with the little crimp tool in the middle there and just crimp down on that connection and do the same on the other one. Now we hit that with heat, and that is our power connection all done. Now we can move on to our first connection here. You're gonna want the larger shrink tubing, and you just cut off like a 1/2 inch section or so. We're just gonna run that over top just like that and move it up the wire. Now, as for the lengths here, now we do have these barrel connectors. I like to use this end on the controller and then do this end on the headlights. And ultimately, it doesn't really matter here, but I do like to keep things as uniform as I can personally. So that's the way I do it. I'm just stuck with that. Now you've got our 8-pin and our 6-pin. So the short wire has that DRL. So we're gonna go with the 8-pin. And for that, I'm just gonna strip off the extended wires here. Whatever is exposed on that, just cut all that stuff off, and then strip back just a little bit more on that and expose all 8 of those wires. Now we're going to strip back all 8 of these, just like so. For the colors, we have black, white, like a brown, blue, orange, green, yellow, and red. And the way I like to do this, I like to double up for the power and ground, since it's gonna be the heaviest load. Your turn signals, your DRLs, and your data are all really low loads, so you don't need a big, thick wire to carry that load. So what I do is I'll take the brown and the red, and I'll put them together. I'll take the white and the black, and I'll put them together, and that'll give me my power and my ground. And that just makes up for the fact that the wire gauge is a little bit smaller, and overall for me, I haven't had any issues using this thinner stuff. Now on this braided sleeving, you are going to want to make sure that it's going to cover up partly up onto this part of the wire here, just to make it look better cosmetically. So you figure out about where it is in the sleeving and then just kind of measure it out, and I'm like just perfect right where it's at. So I'm gonna go ahead and pull this back, and then we're just gonna make sure that all the wires are even length, and then we're gonna cut them just like that. And then we're just gonna go ahead and pull that braided sleeving back so we can get to the wires here. Now on the wires, what I like to do is I'll take a clamp just like this, put it on there, and that will keep the braided sleeving out of the way. Otherwise, the thing's just going to be moving up on you the whole time that you're trying to get everything soldered together. So then I'll take the wire strippers here and just cut them back just like we did with these. I'm going to grab my 3 32" shrink tubing here, just cut 5 lengths so that I can put them over each one of the wires, and then we're going to start splicing the wires together. And just keeping in mind that I am using the red and brown for power, the black and white for ground. I am not going to use the orange wire. The green is going to be my data, and in the case of my builds, I do the yellow as my DRL wire and the blue as my turn signal wire. And that's just something that I was doing years ago because of the wiring that I was using. It was actually 4 conductor, the same stuff that I use now, but just with 4 instead of with just 3. And the extra wire on that was blue, and typically I used it for the turn signal. So to make it straight in my head, I just used blue on here for the connection to the plugs, and I've just stuck with it ever since. But you can certainly change it up if you prefer to use the yellow for your turn signal and the blue for your DRL, you can do that. All right, and then just like that, I got all those wires together, soldered and shrink tubed, and we're gonna go ahead and pull up our braided sleeving. Just try to make that look as nice as you can there. And then we are going to hit the shrink tubing on there. And that is the first side. And then we're gonna move over to this side. We're gonna do the same process. As for the 6-pin wire, I use the black and white, and then I use the yellow and red for my power. So yellow and red for power, black and white is my ground, green data, blue turn signal. All right, just like that, I got both plugs done. As you can see, it looks pretty good overall. Now we're gonna go to the, so I generally like to run these through the back of the light through a cable gland. So you just drill a little hole, put a cable gland in, run these through, and then you can have all your wires connected to the back side of these. Once again, following the same suit where you have your powers and grounds combined, and then you have your data, DRL, and turn signal, or just your turn signal and your data if it's the 6-pin plug. Now I like to make my own JST connections. You can actually get pins and JST connectors on Amazon for a relatively cheap price, and you can get them in bulk, and then you can make your own plugs. And that way you don't have to use an existing plug, you can create your own plug instead of having to solder wires together. It ends up just being cleaner overall, and in general it's actually a little bit easier to do than to have to solder a bunch of wires together to add a pigtail. If you decide to go with that, this is the tool that I have been using for a while now that has worked really well for it. There's a bunch of different crimping tools you can get. I will put a link for this one specifically, but it does have a size that's just perfect for this stuff. I can put 18 gauge wire into a JST connection and it fits pretty good. Can't really go any bigger than that on a JST, but I generally do 18 and it's okay. In the case of these, it will be a little bit smaller at about 20, 22 gauge. So connecting the pins is pretty simple. You can just put it right over top of the wire there. I like to crimp it with a pair of pliers just to hold it in place, and then crimp it with the tool, just like so. Now, if you're doing thinner wire like this, you don't have to actually put it around the wire first. But if you use an 18 gauge, it's really difficult to slide the 18 in. But normally what you can do is you can just take this tool, put the pin in the tool, like so, and then just insert the wire and crimp it down. And that'll work perfectly fine on smaller gauge wiring. But if you are using the 18 gauge, then you're going to grab the 2 wires, put them together. It'll be easier just to grab it, crimp it a little bit, and then lock it down the rest of the way with your crimping tool. Now, as for the wiring diagram for the JST plugs, the standard is if you're holding it like this with that tab facing down, you have your ground, data, and power in that order. So it is important to get that straight. Make sure you don't get that messed up. If you're not sure, you can always grab something like a halo or a strip and just compare the colors on the wires on that and just match it to the plug that you're creating. So now that we have 2 pigtails, we can go ahead and test our controller. So you're just going to make sure that you line up your 8-pin with your 8-pin hole, push it in place, lock it down. Then you take your 6-pin and your 6-pin, push them in place and lock them down as well. Something else you can do that I don't normally do myself, but it's probably not a bad idea, is to color coordinate the wires. So in the case of both of them, they actually look pretty similar, and it is possible that you might have somebody get the 2 mixed up, and if they're plugging them in or something, they could inadvertently flip them. In general, this is not the issue for me in my builds because the short wire generally goes to a set light and the long wire goes to the other light, so it'd be difficult to get them mixed up. But if it is a concern, that's something pretty easy. to rectify with some colored electrical tape. So if you just take 2 colors, I got blue and yellow here, and you just take one side and wrap the base of the plug one time and just do that on both sides, then you will have color coordinated plugs. And that will make it easier visually to ensure that somebody is not plugging the wrong plug into the wrong hole. So now I have blue and blue and yellow and yellow. That way it's easier for people to not make the mistake of plugging the wrong plug into the wrong hole. Because unfortunately, if you do force things, you can bend pins and create other issues. I have not really seen it happen a whole lot, but there was one guy one time that did, kind of impressive, but he was able to get the wrong hole and bend a whole bunch of pins. That was interesting to see. Fortunately, it didn't mess up the controller or anything, but I did have to replace the plug. So now we are ready to test the controller. So I am going to go ahead and connect my power and ground to my benchtop controller here. It is once again important that you do not get these mixed up. Don't put your power to your ground and your ground to your power. You will fry some components in here. Don't do it. For testing, I'm just going to be using some of our UCS diffused 12-inch strips here. So go ahead and pull up your app and connect to the controller. I do have a couple in the area here, but I know this one is the EE. I'm gonna go ahead and connect to that. Now, once you're connected, it's not gonna do anything initially. You're gonna have to go to the lightning bolt tab first. In the lightning bolt tab, you're gonna have your switch 1, or whichever switch you decided to use. Might be switch 1, 2, 3, or 4. Just keep note of which one you end up wiring that into. And that is the part that's going to go to the BlueGhozt to activate it. So in this case, if I push 1 and I just push the number 1 there on the side, I should hear a click. And there it is, it clicked right on. I hit it again and that will deactivate. Now there is still a timer on the relay, so it's not going to be instant. It will take a couple seconds to deactivate, but that just ensures that I have the right switch. Then I'm going to choose the basic drop down and I'm going to change that to triggered. And what this does is it gives me the option to choose when that is triggered. So you have different inputs within the application here. You have your turn signal icons, your DRL, your brake, your reverse, and your party mode. So if you decided that you really don't want it activated when the brakes act or when the reverse is active, you can just deselect that. And that way you can pinpoint when the relay will actually be activated. It does not have to activate at all times, but in general for me, I leave them all active. And what that will do is every time that I go in here and I activate a show mode, it will automatically activate that. And so every time that I go in here and I activate a show mode, it will actually automatically activate that relay. When I turn off the show mode, it will automatically deactivate that relay. Once again, it does take a couple seconds to click off. But this does make it a lot more automated, because instead of you having to use the B button to activate a show mode at a car show or something like that, I can do it in the app to activate and deactivate. But this also still gives me the option of the A button, which is also going to be automatic. So if I go in here and I select a whole bunch of show modes, just like that, I can select a whole bunch of show modes by clicking the icon next to each show mode. And then I go down to the bottom here and I can select this time delay between each mode, so it'll run for how many seconds before it clicks over. Then I can hit this pin for external trigger and it will actually save all these settings to the controller. So now it will activate every time. Now it will start up automatically when you do that the first time when you sync it. So you can just push that play button, it'll stop, and then you can pick up your remote, and when you push A, it will activate that mode. So it does give you the ability to use the remote still for remote activations, but it eliminates the need for the B button, and it eliminates the potential issues where somebody forgets to turn the relay off, which has been an issue. Some people forget to turn it on, and some people forget to turn it off. And unfortunately, it does create a little bit more customer support if you are doing this for other people, because they will inevitably call you and ask why their battery is dead or why their lights aren't working. And you have to, once again, try to explain to them it's because they're not using the remote properly. In the long run, for me, it just became more of a nuisance to have to explain to people what they were doing wrong than to just spend the extra 30 bucks and pass it on to them, which is ultimately what you do if you're building lights, and get them a setup that's just less room for user error. Now, what this does create though is a new potential for user error, and that is that they get in here to the app, they go to lightning bolt page, and they start playing with settings in there, which I have seen as well. So just keep that in mind. If you do switch to this style, you're gonna reduce a lot of issues like dead batteries and things, but it is also potential that you're gonna have people come back to you and say, hey, I didn't touch anything in the app, but it's not working. And then they go in the app and show you, and then you clearly see they changed things, because sometimes people do that. Now, moving on, you are going to want to also double check your inputs from your DRL turn signal, things like that. So for that, you can just take these wires that are hanging out of your pigtail and just touch them to your power. Here is my brake and DRL. Here's a turn signal. We've got our other turn signal. So all of those are working right. I can see them in the app here on the car tab at the top of the screen. They lit up, everything was fine there. Do keep in mind, as I mentioned with the brake, if you do end up using the brake, you're gonna have to go into the block tab, create your sections, and then either activate or deactivate your brake input section. So as example, I'll go ahead and create 2 sections here, and I will set the LED count to 4 for the first one, and we're gonna activate the brake, and then the last one we will not activate the brake. And what that is going to do, you can see I was able to make the brake active on part of the light and make the DRL active on the other part, and that gives me the ability to have multiple colors. Now, even further than that, if I want to have 3 separate colors, I can go in here and I can choose brake for one, do a DRL2 for another one, and then just have DRL1 for the last one with that brake deactivated on it. And then I go over here to the car tab, make sure that you have your DRL2 active to a color with the slider scale all the way up. If it is black or you have that little icon in the DRL2 spot, it just means that this slider here is all the way down. So move that all the way up, then select whatever color you want it to be. And then now when I activate that DRL, I now have 3 colors active for the DRL. Once again, this one is my brake, which I can change the color of as well. This one is my DRL2, and this is my DRL1. So this will give you the ability to have 3 separate colors on your setup if you activate that. And once again, you do still have the reverse input as well if you want to have like 4 colors on a DRL, but you will once again lose that animation on startup for that brake input. So as you can see there, the brake goes solid red as soon as it's active, and the rest of the light will do its action. So definitely keep that in mind. I think it's ideal for like demon eyes or something like that, where you don't necessarily need it to do an activation, but you want to have a solid color that activates with the DRL. It works really well for that, and that's what I'm going to be using on this build. I'm going to have 2 different color demon eyes and then white for the rest of the light. So I need 3 total colors, which is what I will be able to get with this. Don't forget to check both plugs. I did check the first one initially, and now I am checking the other side. That seems to be working fine, just like that. And now we are ready to unplug everything and pot our controller. So now we're ready to go ahead and add in the potting, which will make our controller waterproof. So you're gonna wanna take that cap off, remove the screws in case you did secure it in place. We're gonna go ahead and put it down in our box here. Now, potting compound is pretty messy, so you're gonna want a few things. One, you're gonna wanna have it in an environment where if it gets on stuff, it's not gonna be a big deal. So you can have it on a table, but you're gonna wanna have some kind of a mat down or something like that that you can just throw away if it gets messy. I like the idea of a container like this with like a box in the middle, so it's kind of elevated off the ground, but it just keeps it all contained. As you can see, there's already some that has gotten on the box itself, no big deal. I can just throw the tub out, throw the box out, throw all that away if I need to. No cost, no issues there. You're also gonna wanna consider some kind of glove. This stuff is pretty nasty, so I mean, in the end, cleanup's just a lot easier if you just got a pair of latex gloves. I like this Microflex diamond grip stuff. Bang for the buck, it does pretty good, but you can always go to Harbor Freight and get some of their gloves. And then you're gonna want your potting compound. Now there's a few different brands out there. MCR is a pretty popular brand. I really like the Epoxy Seal 9000, and you can get it by the gallon jug from the Epoxy Store's website online. And usually they're running some kind of a deal or a coupon code or something if you look around online. So it ends up being maybe 150 bucks for a full-size jug like this. And it's really good stuff. It cures really well. It's easier to work with than the MCR, and it's more forgiving. This stuff will generally harden even if your ratios aren't perfect, whereas the MCR, I've had issues, especially if it's cold. The environment that you cure this stuff in is going to make a difference. So you probably don't want to have it in a cold environment. You're going to want to have it in a warm one. I keep this stuff in here. I would keep it in the garage, but when it gets cold out, this stuff is really hard to work with, and it doesn't cure very fast if it's cold. And stuff will eventually cure versus the MCR, which if it's really cold environment, it may never cure. So you definitely want to keep that in mind. The environment, the work area that you're working with, you're going to want to have some kind of a mixing cup. This just makes it easier to get your ratios right. This is a 2-part epoxy resin. So you do put 2 parts of this and 1 part of the hardener, and that does come together. So you do have both of them. So in the case of these mixing cups that I'm using, they actually do have a 2-to-1 ratio here, and you can choose how much you're going to end up doing. I'm going to go with the full amount because we're going to need just about that much to fill this. So I'm going to put 2 parts of this up to that 2 line, and then the 1 part is going to go up to the 1 line. So I'm going to fill up the part A up to that 2 line, and then fill up part B up to the 1 line. Now you're going to want to make sure you mix it up real good. So most of the time these measuring cups will come with stir sticks, and it just makes it easier. You stir it all up, make it look all good. Once again, trying to keep it over this bucket. Don't want to get it on the floor if I can avoid it. And I'm going to mix it up as good as I can. Now part A is thicker than part B, so you can usually kind of tell if you're reaching that stir stick around in there and you get to a part that feels a little thicker, a little bit harder, that means it's probably not mixed up real well, so kind of work on that area. Once the entire mixture just feels consistent, then you've got a pretty good mix. So now we are mixed up and we can pour it in. Now you're going to want to keep in mind that you're trying to keep it inside. If you pour it directly over top of the battery saver, it's likely to try to flow out the sides. So I like to try to hit it on the front side here. That way it all just flows right down inside. So you're gonna want to take your time pouring it in there, just making sure it goes in nice and smooth and you don't make a huge mess. Also, air bubbles are common with this stuff, so you do want to give it a couple minutes just to make sure all the air works its way out. It is possible with this stuff that you might have a big air pocket in there. So if you just throw the cover right on, and that air pocket works its way out, then you have a whole bunch of PCV that might be exposed to the elements because you didn't fully get it in there. So you usually give it a couple minutes and you'll see the air bubbles start to work their way out on there. Then we're going to put the lid on, screw it in place, let it dry for a few hours. If you can give it 12 hours or more, it's not a bad thing, but most of the time this stuff in a warm environment is going to be cured within 2 to 3 hours. MCR, I would give it a full 24 hours because that stuff can take a little bit longer. So it depends what kind of compound you're using. Like I said, I do like the Epoxy Seal 9000. You can get it on the Epoxy Resin Store's website for a reasonable price. And if you're doing it in large volumes, it's definitely the way to go. They also sell it on Amazon in a smaller container. So if you're just building one controller, that's a good way to go. So that is it. I let everything dry overnight, came back, everything looks good to go. I have my remote and the controller, and it does in general just look pretty clean, and install should be pretty simple. So it gives you guys an idea of how I'm building them currently using the new boxes. These are available on MakerWorld. You can download the file and print them yourself. And I will be working on trying to get them on the website. So look forward to that soon if you just want to buy a box from me instead. Thanks for watching. If you found this video helpful, don't forget to like and subscribe so you don't miss any future videos. And be sure to check out nextlevelneo.com for all of your LED lighting needs. Thanks.